Hi 6th graders, this is Mrs. Gall. Today we're going to talk through histograms. Get your notebook ready and press play when you're ready to continue. Some important things to know about histograms is they're a type of bar graph and they show trends of data on a number line. They also group data into equal intervals. There's 4 shapes of histograms that you're going to have to remember. It helps to trace a line along the bars to help determine which shape each histogram would be. When we have a line that creates a bell shape, we call this a normal histogram. It has a single peak in the center and it's balanced on both sides of the data. When we have data where the bars are relatively close together, when we draw that line, there's not a ton of difference. That's what we call uniform. This is a relatively flat shape. So normal, single peak in the center, uniform, relatively flat. There's 2 other shapes you'll want to know. Bimodal is when you have 2 bars that are occurring more than the others. Bi means 2, modal referring to modes. So we have 2 of those bars occurring more than the rest, and there is a dip in between the 2 taller bars. The last shape is skewed. This looks similar to the normal, except for one side of the data is going to be higher than the other. So notice we have this peak and then it kind of slowly trails off. And it can be skewed to the left like this graph or also to the right. There's many acronyms you could make to remember these. Some people do NUBS. Another fun one is BUNS. So you can always write down that acronym to help you remember those 4 shapes. Let's analyze a few things that this histogram shows. First, we notice we have a title at the top. This histogram is about American League wins. You'll also see that our number lines contain numbers as well as units. So we have our label at the bottom telling us this is number of wins, and then off to the side we see the frequency, which is how many times those numbers are occurring. You'll also see that histograms often put the number of data points in an interval above each bar, so it's very clear. And then something very important about histograms is the number line does not have numbers written underneath the bar. They're written on the lines, and that's very specific because each range here is an interval. It's not a single number. Comparing a histogram to a bar graph, this is the same exact data. You'll notice there's less bars in a histogram because we're looking at a range of numbers, an interval, not just a single data point number. You'll also notice that since we only have one data point over here at a lot of different numbers, just one time, it's creating a lot more bars that are just at the same height. Whereas if we group some of those numbers together, it allows us to kind of see some differing trends with that data. One other thing we want to mention is down here we don't see anything labeled under the bar. This one has a color code. A lot of times you'll see something labeled right under a bar on a bar graph, but with these histograms we don't see something labeled right underneath. We see the labels on the lines. Let's go ahead and create a histogram together. I'm going to try my best with the space I have below. So this is data for National League wins. And we want to group our data into intervals along an x-axis, that's the horizontal number line, and then we're going to count how many data points fall in between each interval. We do not want any space between the bars, so I'm going to try to do this right here. We're going to draw a L-like shape for our graph. There we go. Along the bottom, we're going to group our data into intervals. We want to count by something that will include our minimum to our maximum. So I might start at 65 since my minimum is 68. And I'm just going to count by 5s. So I'm going to label each of these counting by fives here. And I need to make sure that I at least go up to where my maximum is, which is 103. So I want to make sure I get to 105. Might be cutting it close on space here. Okay, so we found an interval, and we count by that interval until we get up to above our maximum, 105. Now up the y-axis, this is just going to be how many data points are occurring in each interval, so it usually makes the most sense to count by ones or a smaller interval. Go up to 4 if we need to go higher, we can. Now we're going to count the number of data points in each interval and draw a bar for it. Something that's very important here is each interval looks like it goes from 65 up to the next number, 70, but it actually does not hit this number until you jump into that next interval. So this interval here is 65 all the way up to 69, and then once we hit 70, we jump into the next interval. So let's count so I can kind of show you what we mean by that. How many values do we have in between 65 and 69 since we don't want to count 70? 4 data points. So I'm going to draw a bar for that interval up to the 4. And you could write a 4 above or inside of that bar. Okay, my next interval is 70 through 74. Notice I didn't say 75 because that would be the next interval. So I have 2 data points in that interval. So we're going to draw a bar. And notice there's no space between bars, so I'm connecting it to the last. Next would be 75 through 79, 3 data points. 80 through 84, I have no data, so I can leave it blank or write a 0. 85 to 89, I have 3 data points. The only time that a space is allowed between bars is this when there is no data at one point. 90 through 94, I have 1 data point. 95, I have 1 data point. And 100 to 104, I have 1 data point. That is what my histogram would look like. I do probably want to add a title here, so at the top I could say National League wins. Sorry, I'm trying to write this on my computer. At the bottom would be number of wins. That's what this label could be down here, number of wins. And then oftentimes we see that vertical number line, the x-axis, labeled as frequency, which is just number of times each data point occurs. So you could write frequency here. And that is what we would need to create a histogram. Let's go on and analyze a histogram. This is top grossing movie tickets sold in 2016. These are number of tickets rounded to millions, and this is how many times a data point in that interval occurred. Which landmarks, if any, can be found by reading this histogram? Although some people might argue that you can find the minimum and the maximum, you truly can't, because all you know is that the minimum has to occur somewhere between 20 and 29 million. You have 1 data point in that range, but you don't know what the exact data point is. So because we're dealing with intervals, it makes it very difficult to find landmarks. We're not able to really find the mean or the minimum, the maximum, or the range. We're not able to find the mean because we don't know what these data points are to add them together. We're not able to find the exact median, but we can determine which interval the median would fall into by doing a high-low method that would allow us to cancel out and figure out where that median would fall. So we actually cannot find any landmarks. We can answer questions like this, however. How many movies sold between 30 and 40 million tickets? So we'd want to find those intervals, 30 and 40, and figure out how many movies are in that interval. 2. So that would be 2 movies sold that range of tickets. How many movies sold at least 50 million? When you see the term at least, that means 50 million or more. So you want to look at all data above 50 million. In this case, it's just this one interval. Again, 2 movies. How many movies sold more than 40 million tickets? Find 40. More than 40 is all of the data above 40. So we have 5 data points in this interval, 2 data points in this interval. Together, that's 7 movies. What is the general shape of this histogram? Oops, let's go ahead and draw it. I could see skewed or normal here. The center, it's slightly off-centered, so maybe more of a skewed shape. However, we don't have an odd number of bars, so that makes it difficult to be a perfect normal shape. So slightly skewed would probably be the best choice there. The last part we want to talk about today is we want to analyze these 3 histograms and decide which one of these contains an outlier. Just a reminder that an outlier is an extreme number that's very small or very large than the rest of the numbers. It's usually kind of a loner number that's all out on its own. Which one do you think might contain an outlier? Although sometimes people will get confused and look at the height of the bars to help them decide if there's an outlier, it's actually not fully what we're going to focus on here. What we're going to focus on is if there's a gap in our data. That means there's not data and then all of a sudden we have a data point showing up later on its own. Or there's data, one data point, and then a gap, and then a bunch more of our data. So which histogram do you see that has a gap in the data? Histogram A, we have a bunch of data, and then we have this big span where there's no data at all, and then we have one data point floating off on its own. That's an indicator that you have an outlier in your set. Not a jump from 12 to 4. That doesn't really mean much because all these numbers are so close together. It's when we have space or a gap in our data, a 0 on our histogram, or more than 1 0, that will usually indicate we have that outlier. All right, you guys, the last thing today is to talk about our pros and our cons of histograms. Pros, it groups data to show trends. It easily shows the shape of our data and also easily shows outliers. Cons, it does not show us any landmarks. I hope this helps. Check in with your teachers if you have any questions.